Let me explain number 10 on the homework. They want you to determine if f of x and g of x are inverse functions. So in order for you to do that, you have to verify that your f of g of x equals x. So in other words, you're going to plug in your g of x into your f of x function, and that has to equal x. And in the other case, you'd have to verify that your g of f of x is also x. So let's start, it's like doing two problems in one. Let's start with this guy. Let's plug in g of x into the f of x. If you're going to plug in this binomial into this x, you better put a parenthesis that's pretty big right there, right? So we're going to plug in g of x into the f of x. Plug in g of x, which is a binomial, into the f of x. So let's first start by, instead of doing x plus 6, let's go parentheses plus 6. You guys understand that? Okay, now I'm going to plug in my g of x function, which is really x minus 6. Now let me ask you something. Is there anything to distribute from the outside to the inside? No. So the parentheses are unnecessary. Sometimes you'll have a 3 out here. You have to distribute the 3. But there's nothing to distribute. The parentheses are pointless. So what you really have is x minus 6 plus 6. And what's x minus 6 plus 6? It's just x. So far you verified that it's just x. So far so good. So now you need to do the other one, right? Plug in f of x into g of x. Plug in f of x into g of x. Plug in f of x into g of x. So you're going to have to rewrite this x, but with pretty big parentheses. So instead of x minus 6, I'm going to put parenthesis minus 6. And we're plugging in that f of x function, the x plus 6. We're putting it right in there. And of course, again, there's nothing to distribute. So you could just do the x plus 6 minus 6, and you end up with just x also. So you verified that g of f of x equals x, g of f of x equals x, and also verified that f of g of x equals x. So what do we say? We say yes, these guys are inverse functions.